Today what I'll be doing for Unity is I'll be teaching you the basic guidelines, the basic steps which you need to take. Like whenever you are going forward with any project in Unity, you will have to, or any other software, you will have to get accustomed to you'll have to get comfortable with the environment. You'll have to get comfortable with the software. So today's session will be devoted to that. For those of you who have Unity Hub, just double click and go there. So you see three panels here, right? There is projects, learn, and installs. All these are already pre-installed some Unity projects which you can refer, you can learn. You see tutorials I mentioned here. So you don't have to worry about these now. Just go to projects. First of all, you will start with a new project. So under here, go to new. There are templates available to you. One is 2D and the other is 3D. So you can select your template accordingly. Selecting the template will maintain the project in the same 3D environment. Like if you are developing your game in a current scene, which is in 3D, you cannot switch to 2D in the same project. You will have to maintain the uniformity. I'll be showcasing this project in 3D. You can name your project anything you want. Let's just name it workshop. Under here, you can actually allocate the position where you want to store your folder, where you want to store your game. I am storing it under my directory, so it's as per your convenience. And once you have selected and managed everything, you just go to create. This is what you'll be seeing when you open an empty project in Unity. I'm having slightly older version, which is 2019.2. It might look different, but overall functionality is same. You will have the same windows, same but in different orientations if you are using some other versions of Unity. So I'll start off by introducing to you what all windows are present on my screen and what are the functionalities. So first, what you see here is the scene window. This is an empty space which you are seeing here. There is a ground and there is a perceptible sky and a horizon which you can make out. What your role is as a developer is you will be building 3D models, you will be building stuff, you will be writing codes, you will be designing your own gameplay so that you create a virtual environment inside this empty space. Since this is a 3D space, we are trying to manipulate objects in the 3D space, but our laptop screen is 2D, right? So navigation is a bit difficult in 3D. How do you navigate in the space? You are given three axes here. There is the green one is Y. The green axis which you are seeing is the positive Y axis. The red one is the positive X, and the blue one is the positive Z. So navigation is basically, if you're using a mouse, you will just hold on to your right mouse button. You will see an eye icon popping up. So this what makes looking around in the scene possible. Suppose you want to drag along the screen. So you hold on to your middle mouse button. So you see a small hand appearing. This shows that you are just dragging along the screen. So let me just add an element so that you can actually see the changes. So I've added a cube in the scene. I'm just looking around in the scene and using the middle mouse, I am dragging along the scene. When you hold on to the Alt button and the left mouse button simultaneously, you will be able to rotate around the cube. If I want to look at this cube from the Z axis, you just click on this blue one. You see you are looking at the cube from the Z axis. I want to look at from the top, that is from the Y. I'll just click on it. So in this manner, you can just change your viewpoints, and navigation is made pretty easy in Unity. Let's come back to the scene here. What you see now is an empty space, right? Let's remove this cube for now. What you see now, this a small sun-like icon and a camera-like icon. Inside, when you see this window named as hierarchy, this hierarchy basically stores the information for the scene. Scenes are basically Unity spaces where you are able to design levels, where you are able to design your content. If you want to create a level of some game, what you can also do is create another scene. Like you can just right click here, go to create, and create a scene here. Yeah, inside the scene, you will be seeing there is a main camera. You see a frustum kind of thing appears, and a directional light. So let me talk about the camera now. This camera is what captures the gameplay. This scene is what you will be seeing when you design the game. As a developer, if you are developing the game in this scene, you will be seeing the game as a developer when a player plays the game. So what the player will be seeing is the camera, like what the camera captures. Like when you build a game, when you publish a game, the player will be able to see only those things which appear in this window. So that is the role of a camera in your game. Let's come to directional light here. Directional light is what lightens up the scene. You can see some high graphic end games where you find that if there is a cycle between day and night, so you can create sun of your own and you can just make it circle around your game scene 24 hours or based on the timeline, and you can get a simulation for a day and night. You can also create a flashlight, or suppose you are playing NFS or some asphalt, then you can add light at the headlights or the tail lights of the car. So lighting is very important in game. Seeing that when I'm selecting this main camera here, in the inspector is been filling up with some information. When I go to direction light, the information changes. This information is what we call components of our game object. This shape which you see, the small white colored cube, this denotes that your main camera is a game object. Then your direction light is a game object. So any component which you have in a scene, which you are working on the current scene, is a part of the game and you call it a game object. So my main camera game object has components. Under the inspector, you will find the components. What are components? Components add characteristics to your game object. It also stores valuable information. Like the main camera has the transform game component, and this stores the information about the position of the game object, its rotation and scale. Position, it shows that its x coordinate is 0, its y is 1, and z is -10. That is, my camera is at a coordinate 0, 1, -10. Similarly, rotation, it is rotated with respect to this standard axis, y is 0, 0, 0. And its scale is 1, 1, 1. Like, scale is basically how you resize your game objects. There are various informations on the camera. So, say you are trying to make a mini map, then you can just go to the projection and make it orthographic, and you just see a flat screen here. So in this manner, you can change the camera features, you can change its characteristics, and this was what makes variations possible in a game. So let me add something into my scene. What you can do is just right click on the hierarchy, go to 3D objects, and you have various specific standard geometric shapes available, geometric figures available. So let me add a cube to my scene, and you want to focus on your cube. So just double click this. Once you have successfully added the cube onto your scene, let's say I don't want the cube to be here. I want my cube to say lie here. How do I do that? How do I move the cube from here to here? You see, when you select the cube here, you see 3 axes: the Y, the Z, and the X. So if you just press on one axis using your left mouse button, you can translate the cube along that axis. Like currently I'm translating along the Y axis. You see the game view also, the motion is upwards along the vertical. If I want to move it along the Z axis, you see the axes are clearly mentioned here. You can just hold on to your Z axis arrow and just translate. It will move along the Z axis. It will only move along the Z axis. It won't move along the Y or the X. Similarly, you can do the same thing for the X. So as I previously mentioned, I want my cube to be present here. So I'll drag it along the X and then drag it along the Z. My cube is there. What if I want to move my cube along the XY plane? Or let's say I want to move it along the XZ plane. How do I do that? You see these yellow highlighted regions, right? This green one which I've selected now. This small square which you are able to make out, I hope. When you hold on to these, you will be actually able to move along the plane. The cube is moving along the XZ plane. It's not moving along the Y. In this manner, you can move your cube. Inside the inspector, under the transform component, note the position. You see X is -2.42, Y is 2.01, and Z is -5.2. Let's say I'm dragging it along the Y. Note the position Y. Now I'm dragging. I'm pulling it downwards, and the Y value is decreasing. Now I'm pulling it upwards. You see it's increasing. So it's basically what I'm trying to show you is transform position stores the position of the cube in the world axis. You see, this is the world axis which I'm calling. This is your world and this is your standard axis. You see small icons here, right? The hand tool. It's the same thing which you do with your middle mouse button. You don't need to worry about this. This small icon, the four arrows, this just moved the cube. This recycling type of arrow. Now you see what is happening. You can make out the colors, right? Like this one is red, then this is green, and this is blue. It corresponds to the axis. Always remember, the blue corresponds to the Z, the red corresponds to the X, and the green corresponds to the Y. So let's say I want to rotate my cube about the Y axis. So how do I do that? Go to the green one, which corresponds to Y, and hold on to it and drag it along the screen. You can rotate along the Y. Please note the transform.rotation value, the Y axis. Y value has now become 11.11, 0.005, and when I rotate it further, it's decreasing further. So in this manner, you can you can also, you don't have to just select this. What you can also do is just go over to this rotation, and when you go over this X, you see two arrows are appearing side by side on our cursor. Hold on to your left mouse button and pan it. You are rotating your cube. Just look at the game. You are rotating your cube along the y-axis, about the x-axis. So you can adjust your cube at any desired orientation at which you want. What I want now is I want my cube to revert back to its previous state. Like I want its x coordinate to be 0, 0, 0. I want its rotation to be 0, 0, 0. I want everything normal as it was before. I'll just go to the transform, and you see the small settings like icon at the extreme top right. Just click on that and click on reset. This will reset the values of the component transform. Your position got 0 everywhere, rotation got 0, and scale got 1, 1, 1. But what is scale? So when I go to the scale tool, I see similar three axes. For green one is the Y, blue one is the Z, and again X is the red one. So when I hold on to the X, you see what is happening. Just drag it. My cube is increasing along the X axis. Correspondingly, note the scale value, X value of the scale in the transform. It got 4.6563. So I'm increasing the scale further. So now my cube has a dimension of 10 into 1 into 1, where 10 is along the X axis. So it has basically become a cuboid now. In this manner, you can use basic shapes, you can use basic geometric figures, and resize, rotate, and reposition them in such a manner that you can actually create low poly 3D models. So this proves very useful in Unity. If I want to say spike it up along the Y axis, I'll just go over to the Y. You will see the two arrows again. I'll just hold on to it and pan it. You see it's increasing along the Y. It is becoming kind of a wall. So yeah, I can use this as a wall for my house. So in this manner, you can resize, you can change, you can make variations to your simple cube or any other 3D figures, and you can generate interesting models. So again, I'll bring it back to its original place. Fine. So let me introduce this bottom half. I have introduced this portion. I have talked to you about the scene. I have explained to you what the game scene, game window implies. I've also spoken about the inspector, which stores the information about the various components which you can add to your game object. Components are basically informations which you add to your game object to make them behave differently. Now let's come to this project here. What does project imply? So as you see, I have an assets here, and this is basically a mini directory which you see in your unit. It's nothing different. If you just right click on it and go to show in Explorer, it basically takes you to the place where you have actually saved your project. There is nothing else, nothing different here. Whenever you are trying to, like, you have made some 3D model in Blender and you want to import it in your game scene. You can directly drag its prefabs from here onto your game scene and work. You can maintain different folders inside here and you can do all sorts of work. Then comes the console. What console does is it provides you constructive feedback. And suppose you are running your game and you have written some code, and what happens is if you it might happen that you have incurred some error. So how do you debug it? How do you know where the error is occurred? So in the console you can write your code in such a manner that you can get feedback at what point did you get the error. Like you can write your code in such a manner. Like there's a command using debug.log which you can print some statements in your console. You can actually debug your errors. It also provides you information about the gameplay, like what is happening, which game object is being referenced, what is being called. So all these informations are presented inside the console. And this is during runtime. Remember that the console presents you the messages when you are playing the game, not during when you are editing or developing. This was all about introduction. Now let's play with Unity physics. Unity has given you a world actually. You can create your own reality. What happens when you drop a ball from a height? It falls down. You can also emulate that thing in Unity. Like if you throw a ball, it will follow a projectile motion and fall at some distance. Similar thing can be implemented in Unity. So what I'll do is I'll go to the cube. Okay, let me introduce the mesh renderer first. So mesh renderer is what makes this cube visible. If you want to just switch on and off a component, like I want to switch off, I don't want this mesh renderer component to be active. So I'll just toggle it off, and you see the cube has disappeared. We can only see its boundary. This mesh renderer is what makes things visible in 3D. Obviously, this cube will be stored in the computer in some form of binary digits. We can't understand the binary code that this binary represents a cube. So for that, this mesh renderer converts that binary into actual surfaces so that we can make out a cube. After that, you see box collider. So this box collider component adds a boundary to the cube. A boundary in the sense like box collider enables collision. Two game objects with box collider on will collide with each other. They will respect each other's boundary. They will not diffuse with one another. You see these three buttons here, right? There is play, there is pause, and there is step. So when I hit the play button, as the play button starts, you will see all other things will be blackened out. When it turns blue, your game has actually started. And what you see is in the game window is what will be shown when you actually publish your game. All that your game is having is a cube just floating in midair, and nothing else is happening. We have to add elements to make it interactive. When you are playing a game, you can also use this pause button to pause in between. Look at the console to see what errors have popped up so far or what things have happened. Then again resume your play just by toggling it off, and then the play continues. What you can also do is this is the step button. What this step button does, when you are watching a video, MP4, a video is a series of photos which comes in at a high frequency so that your eyes visualize them as if they are a continuous motion picture. That what happens in Unity also. Your system runs in some say frames per second. These FPS which we talk about in games, the frames per second is done in using step over. Like when you click this once, the game goes forward one frame. Then when you click it another time, the game goes forward the next frame. So frame by frame it takes the game forward. Like if you are executing some functions, if you are executing some script which runs every frame, which is called every frame. So you can see that happening. You can see the results in the console one by one. That like if I click it once, you can see the result of the function. Then I click it another time, you can see the result again. So in this manner, you can analysis of your game becomes easy. So this was about the editing part. Now let's play with Unity physics. So what I'll do is go to add component. You can add any component, any features to your character you want. So I'll be adding a component named rigid body. The rigid body has mass drag, angular drag, use gravity, is kinematic. All these things are there. So earlier when we had pressed on the play button when we were playing our game, the cube was doing nothing, right? Like it was just standing still in midair and doing nothing. Now let's just, after adding rigid body, let's hit play and see what happens. You see our cube fell down and it's continuing to fall down. Like it's going to infinity. We have actually simulated a gravity in our game. So using rigid body, we have added physics component. We have added the feature of physics to our game object. I don't want the cube to continuously fall down, right? I want it to land on something after falling. Like there should be a ground in my game. Let's resize my cube. Okay. So I'll resize it along x-axis. This is a cuboid now. So I'll just go to my hierarchy again. Then under 3D, you will find plane. Click on it, you will get a plane. It's basically a 3D object. If I try to change the Y, you see nothing is happening. Yeah, when I make it negative, obviously it will overturn itself. So try keeping it positive. But if I scale it along the X, it will increase along the X. If I scale it along the Y, it will increase along the Y. What I want now is I want to see how my cube and my plane interact. Before that, you see this cuboid and my plane is mixing. Like the color is both of their color is white and I don't know how to differentiate between them. So what I'll do is I'll add color to this cube. So I'll go to assets. I want to maintain a folder. Let's say I'll just create a folder like this by right clicking inside the assets. You go to create. Then the top option, you select the folder. You will get a new folder. It's similar like you create a file in your C drive, in your D drive. It's just similar. I want to create a folder named materials. Double click to open the folder. Inside that, right click, go to create, then material. This option will appear. Just name your material. Let's name it red. Click on this one. You see inside the inspector again some information has popped up. My material is white in color. I want to make it red color. Go to main maps. Beside this albedo, just click on this color and you can make your own color. Like you can try mixing, you can try various other variations. You can even set the hexadecimal values. As per your convenience, you can adjust the color. Let's keep it red. You see my material got red now. My cube is still white. I want to make it red. Just take this and drag onto your cube. When you go to the cube now, when you select the cube, you will find this red shader appearing, the material. Okay, let's say I want my solid to be metallic. So what I'll do is just tweak this value to some, say, like this, and you see it is kind of reflective. It is kind of becoming obsolete to reflective. You can just change the material smoothness and how it's getting blunt like this. So in this manner you can change and adjust your material, how it appears, how it looks. Previously we had seen that our cube was falling down in infinitely. There was no ground to land upon. Now we have added a ground. Let's test it again. Let's see what happens. Let me drag it a bit higher. My rigid body use gravity is enabled. I'll just play. You see it fell down like an actual object. If I drag it up again, it falls down. Let me change the orientation again. Okay, so it's landing perfectly. You see the cube is landing on the plane and it's resting on it. So what makes this happen? The cube had this box collider on and the plane has its own mesh collider. So both these colliders will interact with each other and they will set a boundary for their respective objects. They will prevent any other collider to enter their collider boundary. Like this mesh collider for the plane will prevent the box collider of the cube to enter it. In the cube, I go to is trigger. What if I enable this? Let's see what happens. I'm hitting play. You see what happened now? My cube fell through the plane. It acted as if it was not a solid. It just passed through the wall. It just passed through the ground. This is what happens when you enable the is trigger. For landing cases, you generally switch this off, and it will just fall down. So let's test it with another object like a sphere. I'll go to the materials and I will select red. I want to duplicate my material. So in the keyboard, I will press Control D. So I want to, let's say, keep it blue. I'll just drag this material again to my sphere, but it's not visible in my camera. So let's bring it into the picture. I'll just translate it horizontal so that it comes in the field of view, that it is below my cube. Let's see what happens when we hit play. The sphere had a box collider of its own. The sphere had the sphere collider of its own, and it interacted with the box collider and prevented it from coalescing into one another. Let's add a rigid body. Again, I already have the rigid body selected. Click on it, and it has the use gravity enabled. Again, I will play. You see the interaction that is happening, and after the impact, the ball experienced some force from the cube and it rolled off the rolling off and it fell down the table. I've actually implemented real world objects inside my game here, and you can actually make other variations like I'll just duplicate the sphere here, and both these spheres are in the same position, and both have their sphere collider on, but I have this sphere inside the sphere one inside the sphere. If I drag it ahead, you see there are two spheres, but I'll just place the sphere one inside this sphere. So let's see what happens. With the sphere collider on, it just separated each other and it fell down. One sphere collider will not stay inside another sphere collider. So in this form, you can add cool features to your objects, 3D models here. And yes, you play around with these components today. Just try what happens when you increase the angular drag, what happens when you increase the mass, what happens when you enable this kinematic, or try checking out other components, what all are present. You see there are so many components present here. Okay, so far try these. I guess this wraps up our session today.